Cool. This is a revision video of portfolio management, and we have covered like three sessions on portfolio management, 3 to 4 sessions on portfolio management. So it's good if we have kind of a recap of everything we have discussed in the portfolio management. Cool. We started portfolio management with a very basic concept saying that it's not necessary that every time you want a higher return, you have to have a higher risk. No, it's also possible that you can earn a higher return at a lower risk. And what we discussed is that we call it as the benefit of diversifying the portfolio correctly, diversification benefit, right? So we discussed that it's not necessary that if you are investing in stock A and earning a return of 10% at a risk of 5%, and if you want to earn a return of 12%, and for that you have to take the higher risk. It's not always true. You can also achieve a point C where you have exactly the same return as A, but you will have a lesser risk, say 4 point or 4%. So, yes, it is possible that you can earn a higher return at a low risk. But for that, you need to understand how you manage the portfolio, how you take the benefit of the diversification, how you take the benefit of the covariance or correlation. And for that, we defined 6 steps. So, the first step is to find the expected return of an asset. Then find the expected risk of an asset, find the covariance or correlation, find expected return of the portfolio, then expected risk of the portfolio. As in, it's not about finding it, you should understand how you calculate the expected return, expected risk of asset and portfolio, of an individual asset and portfolio. And you should understand how to calculate the covariance or correlation. And if you understand that, then the biggest thing that you can do is to optimize your portfolio properly. You will be able to maximize the return and minimize the risk. But if you look into the first step, find the expected return of a single asset or expected risk and return of a single asset, then there are a lot of things you need to consider. There are a lot of things you need to understand is that it's not about finding the historical return. It's not about finding what the return you have received or the risk you have received. You're trying to predict something. And whenever there is discussion about prediction, statistics is the only thing that comes into play and help us. Statistics are the only proper discussed science which can help you in prediction. Because we are not trying to find out historical return, we are trying to find out the future return, we are trying to find out the future risk. And for that, we will use moment one to find the expected return from statistics. Moment one from statistics. And for expected risk or the future risk or predicting the risk, we'll use the moment two. Moment one is all about finding the center of the data, the central tendency of the data. Moment two is all about finding the variability in the data, right? So if I ask you the question that, okay, the historical return of a stock is, let's say, 2%, 10%, 12%, 3%, or 11% and 2.9%. Let's say for the last 6 months, this is the historical return of this stock, and you want to predict what would be the stock return next month. So the best answer to this question is to draw a line at the center. This line is the center line. I've written it mean, but it's not mean because if this is the data, then you're trying to find out the center of the data. That is the mean, median, or mode. You're trying to find out the mean, the median, or mode, right? And that's the center of the data. Why mean, median, mode is being considered? Because that tells about the center of the data, that is moment one. Based on statistics, these are moment one estimators. But generally, we'll use mean. Mean is considered to be blue. It's written in green, but it's blue. Best linear unbiased estimator or best linear unbiased predictor. Why? We had discussed it slightly in the quantitative analysis sessions. But you might think that the answer to this question is pretty straightforward. Yes, it's a very simple approach. You can have complicated approach like regression or time series analysis. So in the complicated approach of time series analysis, you can say that, hey, the the return can be predicted with the help of the mean that you can derive from the autoregressive model if the data is covariance stationary. If the data is not covariance stationary, then you have to identify whether the data has a increasing trend or a decreasing trend. And if it is a linearly increasing or decreasing trend, which means that the return is increasing with time or return is decreasing linearly with time, then you have to derive an equation like this, which is a linear trend model equation. However, there could be possibility that data is increasing exponentially, and if the data is increasing exponentially or decreasing exponentially, then you have to apply a log linear trend model, right? So with the help of this, you can predict the return, the future return. But sometime the data doesn't have a trend, doesn't have a covariance stationary property, then you have to fall back to what? Regression, where you try to predict the return of the stock by some factors like GDP, inflation, R&D cost management, right? And you try to design an equation like this, which is the regression equation. So you predict the return based on the regression with certain assumption about the error term and the different assumption that goes into the regression. Definitely we cannot talk about the regression in this session, but there is already a session recorded for it, so you can watch a video there. Now you can also predict the return with the help of machine learning algorithm like KNN and PCA. So this is all about finding the expected return of an asset. For the risk of the asset, the best measure that has been identified so far is what? Standard deviation. So what is risk? Risk is the uncertainty. Uncertainty to what? Uncertainty to the expected behavior, to the mean. So how much is the deviation from the mean? How much is the deviation from the mean is that's the risk. So you can find out all these deviations, sum it up and divide by n. That will become the average deviation. What is the on an average deviation from the mean? That's my risk is, and that gave to the rise to the formula of mean absolute deviation. But the problem with the mean absolute deviation is that it doesn't give weight to the higher deviation from the mean. So we know that 11 is farther away from 10 or it is farther away from 2%, then it should be given a higher weight or higher risk weightage. So the weight should be assigned, and the weight should be assigned in such a way that that higher deviation from the mean should have the higher weight. Therefore, what we did a square, and that gave rise to the formula of variance. But the problem with the variance is that it gives answer in percentage square. So to fix this, what we took square root and we got standard deviation as the formula. So standard deviation, which is also denoted by sigma x, sigma, very important, is the notation for standard deviation is the best measure for risk. Okay, you got the best measure for risk. What is step number 3? To find out the covariance and correlation. What covariance and correlation tells you? The covariance or correlations tells you the presence of linear relationship between two entity. Okay, so there could be two entity. They might be related in some way. They could be positively related, negatively related, whatever it is, but they might be related. So you can see that assume there are two stocks like stock A and B. So there could be a relation whenever the stock A rises, stock B falls, or whenever the stock A, falls, stock B rises. So if you see case 1 and case 4, they are moving in opposite direction, and that is called as negative covariance or negative relation or negative correlation. Okay. Now, case 2 and case 3 is about positive relation. So, whenever A is increasing, B is also increasing. Whenever A is decreasing, B is also decreasing. And that's why we try to formulate it in a way that whenever A is higher than its mean value, then whether the B is higher than its mean value or not. And if it is yes, And if you try to multiply A minus A bar into B minus B bar, it will always give you the positive answer. Or whenever there is a positive relationship, if A will fall from the mean value and B will fall from the mean value, A minus A bar into B minus B bar will always give a positive answer. So therefore, you can see in the covariance formula that it is saying on an average, if x is above the x mean, whether y is above or below the y mean or not, on an average. Therefore, you're doing the summation and end, right? Similarly, uh, it will give you the negative result if A is moving above its mean value and B is falling below its mean value, then A minus A bar into B minus B bar is going to give you a negative relationship or whatever it is, right? So this is correlation. So correlation could be covariance or correlation could be positive, negative, or zero. However, the value of the correlation always falls between minus one and zero, minus one and one. Okay, because you divide covariance by sigma x and sigma y. Cool. So you have three things already there, that is expected return of an individual asset, expected risk of an individual asset, covariance and correlation. Now you have to find out the expected return of the portfolio and expected risk of the portfolio. Now, expected return of the portfolio is pretty straightforward. It is weighted average of all the return. Very simple. Assume you have stock A, B, C, D, E, and you calculated the expected return of stock A is 5%, B is 6%, C is 3%, D is 2%, and E is 1%. Then what will happen? That if you do the weighted average of expected return, you will get the answer something like this, right, which is 3.25%. So you have to just multiply weights into return, weights into return, weights into return, and at the end you will get the expected return of the portfolio. However, the expected risk of the portfolio is different for two asset portfolio, which means if you have a portfolio and there are only two assets there, then the formula is WA square into sigma square plus WB square into sigma B square plus 2 into correlation between A and B into WA and sigma A into WB into sigma B. For three asset portfolio, this is the formula. Now, the only thing that you have to understand that there is a correlation between two entity which is impacting the risk of the portfolio, right? This is the risk of the portfolio. There's a correlation between A and B, B and C, and C and A if there are three stocks or three asset in the portfolio. Only thing you need to know that the correlation between only thing you need to remember that the correlation between two asset or two entity always fall between minus one to one. So let's take two asset portfolio and try to find out what will happen to the risk formula if the correlation is perfectly positive. So whenever the correlation is equal to 1, we call it as perfectly positive. Whenever the correlation is minus 1, we call it perfectly negatively correlated. So WA sigma A, WB sigma B, then it is a linear relationship. And if you try to find out the risk return profile, it is going to be a straight line. How come? We'll discuss about it. Now, the case 2, when the correlation is minus 1, the formula will convert into WA sigma A minus WB sigma B. Again, it is linear, and you can see that the risk return profile is again straight line. How it is for correlation is equal to 1, it is coming as WA sigma A plus WB sigma B. Because if you put 1 here, this formula becomes A square plus B square plus 2AB. Therefore, A plus B whole square, and when you take under root, it becomes A into B, where A is WA sigma A, B is WB sigma B. If it is minus 1, if the correlation is minus 1, if you put correlation is equal to minus 1, then the formula become A minus B whole square, and then you take square root, then it becomes A minus B. That's why linear. But if the correlation is any other value between minus 1 and 1, but not equal to minus 1 and 1, this is going to be a quadratic equation and then a square root differently. So it is not going to be a linear graph. So this is very important to understand that whenever the correlation is not equal to 1 or minus 1, the graph or the risk return profile is not going to be linear. It is going to be curved. Let's discuss about these three graph in detail. So we have these Python coded different profile or different scenarios. So scenario one is about case one, okay, where the correlation is equal to one. So you see in this code, we have taken the correlation is equal to one. We have taken two assets where the return is 5% and 10%. So asset A has a return of 5%, asset B has a return of 10%, and asset A has a risk of 2% and risk of 5% is for asset B. Now, what will happen? If you try to plot it, we'll give you the code in the description below. If you try to code it, then what will happen that if you're investing, you will get a straight line, which we discussed. If which means that the leftmost point is A and the rightmost point is B. Okay, which is not true in any other curve. It is only true when the correlation is equal to 1 that the leftmost point is A and the rightmost point is B, which means that if you're standing here, you're investing 100% in asset A. If you're standing here, then you're investing 100% in asset B. And as you keep on increasing the weight of asset B because it is more risky than asset A, the risk is increasing and also return is increasing. Why return is also linearly increasing? Because even we discussed, right, the return is weighted average. WA return A plus WB, sorry, WA return A plus WB weight of asset B into return B. It is also linear. We discussed it in the fourth point, right? So the return is also increasing and risk is also increasing. The return is increasing, the risk is increasing. It's as straightforward because the return formula is going to be linear. It is a weighted average and risk formula is also weighted average. So this is going to be linear. Okay. Now what is happening when the correlation is equal to -1? When the correlation is equal to -1, the return formula is again WA into return A plus WB into return B. But the risk formula is WA sigma A minus WB sigma B, right? That is the risk formula. So again, it is going to be linear. When you're standing at this point, you're 100% invested in A, where the return is 5% and risk is 2%. Now again I'm writing the return formula WA return A WB return B. As you increase the weight of B, the return of the portfolio will increase. But what is the formula of risk? WA sigma A minus WB sigma B. The risk will decrease. The risk will decrease. So therefore, if you see this line here, the return is increasing, but risk is decreasing. So return is increasing at every point, but risk is decreasing. But there is a point where they reached zero, somewhere around 6.5%. The risk is zero, but risk cannot go negative. Now the risk is being dominated by what? WB sigma B minus WA sigma A. So now the risk of B is dominating. And therefore, now the return is also increasing and risk is also increasing. And slowly, gradually, you will reach to asset B. You can actually plot it on Excel as well. What I did here, I started from a weight of asset A at 100% and slightly increasing the weight of B, like 1%, 2%, 3%, 4%, keeping the sum of the weight of A and B equal to 100%. Now, that was a derivation, but I won't enter into the derivation. Now, let's talk about the real world example where the correlation is equal to 0.1 because the correlation cannot be perfectly positive or perfectly negatively correlated as in -1. It has to be between 1 and -1, but not equal to 1 or -1. So I've taken the real life example where the correlation is equal to zero point 0.1. Again, if you see this, then what's happening here that you when you are at asset A, you're earning a return of 5% and risk of 2%. But because in the risk formula, in the risk formula, now this correlation is 0.1. As you keep on increasing the weight of B, because of this correlation, which is not 1 but less than 0.1, the risk will again start decreasing. And therefore, you can see that the risk is decreasing. Return is increasing, but risk is decreasing. See, the risk is decreasing, right? The return is increasing, but risk is decreasing, 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 decreasing. And this is the point, this point, the risk is minimum. You can say it is somewhere around 1.1%. This is called as global minimum portfolio. The risk cannot go beyond this. And then the B will start dominating as it is a risky asset. And again, the return is increasing and risk is also increasing. And at the end, you will again, when you reach here, you are 100% invested in B. There is another one very important concept here. The concept of efficient and inefficient portfolio. Right now, I'm saying the blue line is efficient and inefficient frontier. Now, look carefully. Now, I'll plot something. This section is inefficient frontier, and this section is an efficient frontier. The reason is you will never invest in the asset which is marked in red, or you never invest in the portfolio, the combination of portfolio that is in red. Okay. All the points in this line is what? A portfolio with the different weights of A and B. You will never invest in these portfolio because these are inefficient portfolio. How come these are inefficient portfolio? Let's see. Assume this is a portfolio where you have 80% invested, where you are 80% invested in A and 20% invested in B. Okay. So you got a return and you got a risk. But let's see what's happening here. There exists a portfolio where you have a higher return of 6% at the same level of risk of this portfolio, which you can call as portfolio C, which has 80% A and 20% B. Rather than choose this portfolio where you will have might be like 50% A and 50% B. Why 50% B? Because as you are moving in this direction, the weight of B is increasing. So this is this section, which we plotted earlier. Let's replot it with green. This section is efficient frontier, and this is the efficient frontier which is given by Sir Harry Markowitz. We did it for one asset, but you take 100 asset, put into this code, and what you will get? You will get the same efficient frontier. So your efficient frontier will always look like this. It will never look like this because that section is what? Inefficient. Okay. So with that, we have completed like a revision of 50% of portfolio management. Thank you. Let's meet in another session.